All right, good evening, folks. First of all, I just want to say, as we get started here, everybody finds their seats. Thank you so much for coming. This is an awesome turnout. So I really appreciate you coming and doing some math with us tonight. Tonight's the first of a three-part series, session one. The first two are going to be on bar modeling. This one's grades 1 through 8, or excuse me, 1 through 3. Sorry, 1 through 3, and then 4 through 6 is going to be in about 2 weeks from now on the 18th. It's okay. That's fine. Come on in. And then 2 weeks after that, on December 2nd, another Tuesday night, we're going to do just basic number sense, which is not bar models, not specifically with word problems, which is a lot what bar models deals with, but more just general, how does Singapore math teach addition, subtraction, multiplication, division, mental math, things like that. If you've ever heard the phrase number sense, unpack that on the 2nd. So, if you haven't already grabbed a handout, come on up and grab one. There's one of each of these. We're going to kind of go through those together tonight. There are some icons in the top right-hand corner that will give you a key in for when we're doing a try it slide where we'll all kind of bar model together. That's going to be fun. And there's also going to be some helpful, because one of the main things we want to do tonight is we want to give you tools, even little helpful phrases to use with your students. I didn't learn math this way when I was coming up in school, and I know that none of you guys did either. So there are a bunch of phrases over the last several years of doing this that I end up saying all the time when I'm working with kids, and I've written those down, and those are for you to take home so you can help with homework. If you would take 1 second, I'm going to grab a drink of water. Introduce yourself to your neighbor, please. We're all going to be struggling through 3rd grade problems in a second, so let's get an awkward hello out of the way right now, and then we'll get started. So our goals for tonight, first, are to learn the basics of the bar modeling strategy in Singapore math, to see examples from 1st through 3rd grade textbooks, take a sneak peek at how the bar modeling strategy pays off in the older grades, and work in small groups on the problems that your kids will be seeing this year if they haven't already. So here we go. One of the biggest things about Singapore math, the reason we love this program so much at Good Shepherd, is because it really reinforces on a daily basis, on a lesson-by-lesson basis, a concrete to pictorial to abstract learning process. And abstract is where a lot of us kind of stayed when we learned math, as in to add two numbers, you stack them on top of each other, and if you don't get it, I'll show you again, and we can do it again. And that was about it. Some of us had a more pictorial representation where we had 10 blocks and manipulatives to kind of see what the base 10 system really is about. And that, I guess, would be a concrete as well. But this is really reinforced every single day in Singapore lessons. It's one reason, because we don't want math just to be for the people who get it and understand the traditional algorithm. We have a place to go after that when kids, if and when kids, the traditional algorithm doesn't work for them. They don't see it right away. On a textbook page, it looks like this. This is a grade 2 page. We're actually going to go through this page together tonight, where you see the concrete, which would actually be the manipulatives, and this is really pictorial because on a textbook page, the best we can do is a picture of something that you can actually touch. So you got to trust us and remind your teachers, as we remind all the teachers all the time, they do a great job, saying we actually are touching these things and moving blocks around to really get that concrete in the early grades. Then move on to an efficient pictorial representation. Keyword there being efficient, we'll talk about that. And then we move eventually to the abstract 24, if you can barely see, 24 minus 7 equals 17, which if we're working through a word problem, this is the kind of the more familiar part to us. But we're adding these 2 extra steps really for kids who just don't see it right away, and for all kids to get them where we want them by the end of 8th grade, which is an algebra. So a couple things about Singapore, the bar modeling strategy. This is one element to the Singapore math model. It's visual, it's incredibly efficient, it's simple, which doesn't mean easy. We'll talk about that. And it's very versatile. I can use these 2 bars to represent really an endless amount of word problems that we all went through and solved when we were coming up through school. So let's take a look at how that works. Actually, let's talk about this. What makes a good bar model? Number 1, I get a lot of questions about this from teachers, from parents, from kids. Is my bar model right? And that's a really tough question, especially for a 1st grader who's learning. You know, I wish there was just one right way, but there's really not. So here are the better questions than is my bar model correct? They are, is it an accurate representation of the situation? Because that's what bar modeling is really about. Are you representing what's happening in a word problem accurately? And you can do that in a lot of different ways. Does it lead to an effective operation by which I can solve it? So does drawing this model show me that the answer could be derived from addition or subtraction or multiplication or division? And if the answer is yes to both, or even one of those, then it's a pretty darn good bar model, even if it's not exactly what's in the textbook or exactly the way you would do it as a parent or I would do it as a teacher. So that's a challenge that we'll kind of work through tonight. And here's something I'll talk briefly about. These are questions really more for parents. I would share these with students. I wouldn't share these with students, but I'll share them with you. What makes a good bar model for me, as somebody who's trying to help kids in their learning, is does it show what the student knows and what you don't know? So even if it's an incorrect bar model, if it doesn't accurately represent the situation, I know a lot more about the way you're understanding this problem. And it can be effective for me, if not effective for the kid, in my next steps to help them. And does it provide a framework for common conversation? We'll talk about that. So, grade 1. Grade 1 is huge on what we call number sense, that is our number system, base 10, what numbers are, that they can be broken apart and put back together in a bunch of different ways. There's a huge emphasis on relationship between things and between numbers, things that are more than others, less, taller, shorter, longer, fewer, and that's pretty much the entire summary of the kindergarten curriculum right there. Number sense, numbers underneath 20, and things that are more and less and the same. And first grade really takes it a step farther and lays the foundation for bar models. So let's take a look at this. Excuse me. This is a 10 frame. Many of you have perhaps seen this in the textbooks, or this is something that we use with your kids a lot. And that is just to get at this number sense, the basis of number. I can represent number in an efficient way, that being 0, this being 1, this being 2. And we use 10 frames for counting games all the time in kindergarten and first grade. What we can do once we've established this counting pattern and basic number sense of what numbers are, is I can compare two things. For instance, 5 of these blocks that I can touch and play with in math class and at home, 5 is greater than 3. And using that same model, I can say that 3 is less than 5. At the very beginning of first grade, we haven't gone to how much more, how much less, but that's coming up really quickly. What is 1 more than 3? Here we're just playing with blocks. 4 is 1 more than 3. I've got my first 3 that are the same, and my 1 that's more. What is 1 less than 4? Well, if that's 4, 1 less is 3, and I can represent this with blocks. So these are not terribly difficult concepts, but when kids, and if kids have trouble with these, we have a place to go. Besides, let me just ask you again, it's count it on your blocks. Can you show me on your blocks? Is that right? Can you prove it? Prove it's a big one, that's a good one to use with kids. And if they can, even if they're right, asking them to prove it solidifies their thinking. And if they're wrong, it hopefully can help them catch their mistakes. Then we put our blocks into number bonds. Many of you have seen these number bonds. Basic idea being this is the whole, and these are the parts. And the number 4 can be split up in a lot of ways, including 3 and 1. Basic number sense. Here we get a little bit closer to bar models with the question, what is 2 more than 7? I've built 7 in green blocks, and 2 more is 8, 9, with a total being 9. Here we come to our first word problems in first grade. And here we're really sticking with that pictorial representation of a concrete thing. Megan has 4 red markers, and there they are. She has 3 blue markers. How many markers does she have in all? And we do want the kids to arrive at the efficient way to solve this, which is stacking 4 and 3 on top of each other and saying it's 7. But if they don't know that right away, they have another avenue by which they can solve it, which would be to count them up. I can represent subtraction using, or takeaways, as we call it at the beginning of first grade, with a bar model, or with cubes, by saying, what's 2 less than 6? Well, if I build 6 and take 2 of those away, I'm left with 4. I can prove it, I can show you. Here we get to some more picture representations. 9 birds on a wire, 6 fly away. How many are left? There are 10 muffins. Hector takes some, which is actually a pretty difficult mathematical thing to do, right? If I'm just using the traditional algorithm here, I'm doing 10 minus I don't know what gives me 3, and I have I can count the number of muffins that he's taking away and prove that situation. So it's a little bit more complex. This is a great one because we teach takeaway with, subtraction with takeaway, but here nothing's being taken away. We're just talking about parts of a group. A tree has 7 lemons, there they are, and 2 of them are yellow. How many lemons are green? Well, part of that 7 is the 2 that are yellow, and I'll take those away to get my 5 that are green. Then I take it a step further. The numbers get harder, but notice the really, really familiar way that the kids are organizing this problem. What's 1 more than 15? Well, there's 15 and 1 more is 16. Here we talk about relationship, tall and taller, short and shorter, which are huge, huge things in word problems in 2nd, 3rd, 4th, 5th grade. An understanding of the relationship between two things is just essential. So we really, really hit it hard in 1st grade. And here is, you can see, or you will be able to see, this is really the beginnings of a bar model when we're talking about ribbons. And here, we've got a new novel situation that we're comparing 3 things. And we can talk about one that's taller than the other. One is that the tallest of all. All right. One reason I think a lot of parents and teachers and students have trouble with bar models at the very beginning is because bar modeling is truly a process. And a lot of times in the textbook and when we're looking through a homework problem, when we're called to help as parents, we only see the final product. So on the next slides, I'm going to try and build it with you as we go along through the problem. So Rose has 15 blocks, and there they are. I made 15 blocks and I labeled them 15. Sean has 3 more than Rose. How many does Sean have? Well, if Rose has 15 and Sean's got 3 more, that's what that would look like. Notice that the more is labeled off here to the side, and then Sean's bar is ultimately more. My question mark represents what I want to know, and that's how I start a block model, which will turn into a bar model. How about this one? Mike lives on the 14th floor. He lives, so there's Mike and his 14 floors. He lives 11 floors higher than Nora. Does anybody know, if I were to ask a 4th grader this problem tomorrow morning, the number 1 answer I would get? The question is, on which floor does Nora live? I'll tell you right now that tomorrow morning, if I ask this question, I would see 14 and 11 and the word higher, and here 25. Almost every single time. But that's not really what's happening in the problem. Mike lives 14 or 11 floors higher than Nora, so Nora really looks like that. So this is 14, take away 11, which is 3. And this is what I'm talking about when I say, even if a bar model is not correct, the way a kid structures that bar model can be really, really helpful for me as a teacher. I'm a math teacher, so I think through this stuff very quickly because I've been trained to, but if a kid gets 25, I know exactly what their mistake was. But then how do you talk to that kid about that mistake? Well, if they've drawn a bar where Mike is here and Nora's bar ends here, and we say, who's got more? And the kid goes, Nora. And we look back at the problem. Well, that's not exactly correct. It gives you kind of a framework to talk about the next step with the kid. So, if you see this on a piece of homework, and your student doesn't know how to solve it, a great thing would be, can you show me on some blocks? These are available at bookies, at really any education store. You can use pennies, pieces of candy around Halloween, anything that you can count would be a good step to go when the kid doesn't know. So Sam makes 20 favors for a party, and there are Sam's 20 favors. He makes 6 more favors than Julia. That means Julia makes that many. How many favors does Julia make? That's our question, and the answer is going to be 14. 20 minus 6 equals 14. Julia makes 14 favors. So here are some helpful phrases for 1st grade. Can you show me with cubes? If you got a word problem and your student is not understanding it, this is something that we really prompt them to do every single time. And they can be in charge of their own learning here, right? Instead of, well, you see, Sam's at party, and that kind of language can be really effective, but we know that letting the kid actually build it is definitely more effective, and it puts more of the learning in their court than ours. Are you sure is a great question. Now, I ask my kids this all the time because when I was a 5th grade teacher, I started asking kids if they were sure when they were right. Like if I said, 20 minus 6, the answer is 14. Are you sure? And the kid would be like, definitely. I could raise an eyebrow and the kid would tell me 2 plus 2 is not 4. Because a lot of times the only time they're asked if they're sure is when we're really saying, you're wrong, try again. That's not right. So asking, are you sure, when they have a model by which they can go back and kind of derive the answer again, is not just picking on them, it's really helping them solidify their thinking and driving home this idea that you can be sure in math. It's not just hand your test in, hand your homework in, and we have no idea, we'll see what the grade comes back. That you really can be sure, especially in 1st grade, when you have blocks in front of you on your math homework. And how much is this? This is one I use all the times when the kid makes an incorrect model. So let's look back at this one. And let's say my little buddy gives Sam 20 and gives Julia 26. I'd say, how much is that? And they count it up, and that's 26. Well, should Julia have 26? And just getting back at their thinking so they can understand maybe where their problems come through. And if they can't answer that question, then we'd maybe start over and build it again, or have more of a traditional conversation about, well, that's not right. Let's try it again. Let's do it together, kind of thing. Okay, on to grade 2. Any questions about grade 1? Okay, we're going to have some for you to try here in just a second. One of the biggest things in grade 2 is we move from the concrete, that is counting with blocks, to pictorial representations. This is really true bar modeling now, where we're drawing a really simple picture. And almost always in grade 2, when we start to teach this strategy, our problems are in chronological order. And I'll show you what I mean by that in a second. Mandy makes 10 granola bars. This is the very first bar model the kids ever see in 2nd grade. And what do you see right above it? That recall of what we did all through 1st grade. That is, we counted all the stuff on blocks. Mandy's got 10 granola bars. Ada makes 12 granola bars. How many bars do they have in all? And in 2nd grade, we start to represent that like this. I've got a bar that represents 10. Instead of drawing 10 individual ones, which is very painful for adults and for kids, draw a bar, call it 10. That's if there's one thing you remember for helping your kids on homework, it's that. Draw a bar, call it fill in the blank. Is the best thing. I say it 100 times a day with kids because it helps get them started, which we all know can be a challenge in math sometimes. It certainly was for me. Ada makes 12 granola bars. Are those 12 part of that 10, or are they extra? If they're extra, they're going to be set apart over here. How many granola bars do we make in all? That's represented with a question mark. And I solved this the good old-fashioned way, 10 plus 12 equals 42. Here, we see a subtraction problem. Will buys 24 eggs. There's Will's 24 eggs. He breaks 7 eggs. Well, where did those 7 eggs come from? Are they a part of that original 24, or are they extra? They're a part of it. So I'd represent my bar model this way. Draw a bar, call it 24. Will buys 24 eggs. Draw that bar, call it 24. He breaks 7 eggs. Are those part of this bar or extra? They're part of it. Those 7 go right there. And what do I want to know? How many eggs did not break? Well, if these are all the eggs, those are the ones that broke, then these are the ones that didn't break. And if I started with 24 and took away 7, I'd get 17. Next, in 2nd grade, this is just kind of a little disclaimer. We start seeing a lot of bar models like this. And if you can imagine building this step by step, actually drawing a dotted line that shows the movement of my bars is not efficient, certainly. And it's not really, it creates a lot of eraser work and a lot of, oh, it's something I gave, so I'm gonna start with it over here and like move it slowly towards when I erase each time. Not really, and that took me a long time to figure out. I used to encourage kids to do this the very first months of Singapore math. But really what they're trying to drive home is the fact that it's an action, that it's something that's being given. So my final bar model would look exactly like this without this dotted line. So we don't really need that. If the kid drew it in, that'd be great, but it's not necessary. It's really kind of cumbersome. Okay, so if we look at this one, Jenny has 87 marbles and her friend gives her 78 more marbles. How many marbles does Jenny have now? Let's go back to that question. Is this a good bar model? Let's ask 2 questions. Does this accurately represent what's going on in the problem? Yes, absolutely it does. And does it give me to an effective operation by which I can solve it? It certainly does, because I've got 87 and I've got 78 and I want to know the whole thing. I need to put them together, and all of those keywords tell us it's addition. But I could do it in another way, and that is the way I just discussed, where it looks more like this, just one model. This would be what I expect to see on a student's paper. Here we see other arrows that are just meaning to show us action with a subtraction problem. A florist has 98 flowers. She sells some of them, so an unknown part's going away, and she's got 28 flowers left. Well, if I start with that 98 and take away the 28, I'll be left with my unknown. Okay, let's try this one together. If you would, with your neighbors. Really quickly, I'll give you about 30 seconds. Try and get this bar model started and see how you can do it. I'm going to try and model some of our helpful phrases as you go through this. If you're stuck at this point, number one thing I'd ask you to do is draw a bar. Call it 98. That's my first sentence. Draw a bar, call it 98. Get started. She sells some of those flowers. Next question I'd ask you if you're stuck after drawing the 98 bar is, where did those flowers that she sold come from? Were they part of that 98 or were they extra? she's got 28 flowers left. Where are the flowers that were left? Are they part of that 98 or are they extra? And how many flowers did she sell? Tonight's just about bar modeling, so I won't even make you add or subtract to get the answer. Okay, even if you're not done, to keep us moving, let's take a look up here. A florist has 98 flowers. Draw a bar, call it 98. Boom, there it is. I can get started. And this is what I mean by chronological order. We can the first useful piece of information in second grade is almost always in the first sentence. That's why I'm saying draw a bar, call it blank, is, especially if you have a second or first grader, like the number one thing you can say at home to help get a kid unstuck. Yeah?
Do you ever like have the students put like florist in that bar?
Put?
Like white florist?
Absolutely, absolutely. And when they get more complicated, we'll start to see some that are labeled. And there, there I'd go back to my two questions too, right? Because I get that one a lot. Do you have to label them? Well, is it an accurate representation? And if it's got the labels, it's more accurate, right? Sometimes a lot less efficient because it takes the kid a long time to do it, or they have to go back. But absolutely, that would be correct. Yeah. She sells some of them. That was my step for that guy. Where did those some come from? They came from the flowers, and I've had some really awesome and interesting conversations about small-scale economics with students about where did those flowers come from? Well, they come from something that you sell. It's kind of like if you have a warehouse and they're full of flowers, it gets messy sometimes. But and she's got 28 flowers left. Well, if these are some that she sold, then those are the 28 that are left. How many flowers did she sell? That was that unknown bit right there. And how, now here comes the big part. How would I solve this problem? And if the kid's stuck on that, sometimes this is why we do bar models, because if I don't know that this is a subtraction problem, I now have a framework by which to tell about the fact that it's a subtraction problem. This whole bar, how much is that worth? That's one of those helpful hints. How much is that? It's 98. So how do I get this part? Well, I want to take that part away. And mathematically, what is take away? It's subtraction. 98 minus 28. So I got 70 flowers. She ended up selling 70 flowers. Okay, yes?
Just ask the question.
Yeah.
So when you still threw up the standard stack of subtraction, and earlier in the addition it was something that wasn't terribly round numbers, so you're still in stacking the addition subtraction?
Yes.
Teaching them how to...
Absolutely. And that's like the number...
gets them there, whether it's addition or subtraction, to set up the...
Exactly. So we are still teaching this. And I don't carry it through on all the slides, so I'm really glad you asked that, because that's really an important part of it. That we're not just expecting that they derive the answer from this model. Yeah?
So for a kid who gets this, are we using this opportunity then to introduce them to simple algebra?
Yes. Yes and no. We're getting them used to the idea. I wouldn't tell a second grader that I could call that bar X and take it away, sit 98 minus X. But we're really laying the foundation for that type of thinking. Really, if we, after many, many years the kids having this and our teachers teaching it, we should be able to make a pretty seamless transition into algebra instead of freaking out with letters, because we've been dealing with unknown values for a really long time. It's a great question. Yeah?
I know this is about
Yeah.
bar modeling, but if that was, say, 97 minus
Yes.
28,
Mm-hmm.
in Singapore, you do that the old-fashioned way, like 7, and you take 1 from the 9 and add a 1. Like,
Yes.
Is it the same thought process?
Yes, it is. Yes, it is. And there are other strategies that we teach as well, like, if I can really quick say, 97, take away 28. One strategy we teach, and we're going to talk about this in the number sense one, and on our YouTube page, there's some pretty good videos made by me from about the mental math thing. I don't know if I can say great, but if one strategy we could do, 97, take away 28, I would take away 30 instead, because it's really easy. And what did I do? I made a problem a lot more easier, but it certainly wasn't accurate. So by making that minus 28 minus 30, I took away 2 too many. So what do I do in the end to make it right? Give them back. So I do 97, take away 30, which is 67, and then I give 2 back, and it's 69. So, but we absolutely do have kids crossing out the 9 and borrowing. And when they don't get that, we use base 10 blocks to help reinforce that skill. Great question. Okay, yes?
One quick question. So it sounds like in some ways you're giving kids a system by which to solve this problem, but it sounds like if a child solves it in another way that has no way to do with this, do you accept that, or
This is just an incredible question, because I'm going to be teaching a 6th grader and 5th grader bar models that they cannot just look at and solve. There are many 2nd graders who can look at this and understand the subtraction and know how to subtract it, right? But, so it's a really fine line. I would say, on homework, asking these prompting questions to get your kids to draw the bar models is a really good thing, because it's a skill that we're trying to teach them that's going to pay off big time later. Having a really terrible interaction with your students on Thursday at 8:30 is not a good thing. You know what I mean? And at that point, I would call it and put an initial on the homework and send it back and say, this really wasn't happening last night. Or they're all right, but there's no bar models. That's something we can see when we check homework. So it's a give and take. We definitely, the only reason we teach this is to get here. So it's a fine line between saying it doesn't matter for you and not preparing the kid for later. Does that make sense? Okay, great question. Yeah?
Not graded at all on bars on their tests.
Sometimes we are, because we try as teachers, and this is something we talk about all the time, is we're training, what are you trying to do assess? Are you trying to assess the bar modeling skill, or are you trying to assess whether or not a kid can have? And drawing that line is tricky sometimes as teachers, but we try and do our best on that. But they are graded on the bar modeling, the actual bar models sometimes, for that reason. Okay, comparison bar models. How are we doing on time? Okay, cool. Kesha has 213 pins in her collection. Draw a bar, call it 213, and there's a label, because this one's going to be a little bit more complicated. I actually labeled it Kesha. Fran has 98 more pins in her collection. How many pins does Fran have in her collection? And there we go. 213 plus 78. And this is another one of those things, even though it's written this way, that's stating it, but we would have the kids absolutely be stacking these on top of each other unless they had a mental math strategy like add 80 and then take 2 away because you gave too many. But we're absolutely stacking these numbers in 2nd grade. Common mistake. This is a big one. And this is where bar modeling gets a bad rap for being really, really hard, but really I think bar modeling, even when it's incorrect, tells me so much about what a kid's thinking about a problem and where my problems truly are. Kesha's got 213 pins in her collection. Fran has 78 more pins in her collection. How many pins does Fran have in her collection? And at the beginning of 2nd grade, I tell you, half the kids do this. Because I was taught in coming through school to skim through a problem and pick out the numbers and pick out the keywords, and that's how I solve it. So this is a really realistic way to look at this. But the big thing here is that if I label Fran and truly take this bar model to its logical conclusion, and it asks me how much Fran has, the kids don't answer 78. That's what the bar model says, right? But they don't say that. What do? They add it up anyways, and they come to the right answer because the word more was in there, so I did get my correct answer even though the bar model wasn't correct. So is that okay? Well, they answered the question correctly, so that's definitely a win. But do they understand the bar modeling strategy, and are they coming up with an accurate representation of the problem? And is it a skill they can use later? No. So this is a parent and teacher decision on the spot, really. Is this a battle I'm going to fight because it's really important, or is it 8:30 and this isn't going well, and that's okay. And both are totally legitimate courses of action, I think.
So my question is, how do you know to make 2 bars? Is it comparing?
Exactly. It's comparison. And we do not want kids to have to say, this is a comparison bar model, so I'm going to stack up the 2 bars. What we want them to say is that, did I say it on this helpful one? Or I think it's coming in a second. A helpful phrase is, where's the more? Or where is the less? Okay? And if I show the bar this way, can I label the more? Or where is the more? Well, the more is right there. This is the part that's the same, and this is the part that's more. It's also the part that's less, right? So that's the kind of probing question I would use to get a kid unstuck from that part, is where is the more? And that is the type of thing that tells them it's got to be stacked on top of each other. I did an activity with 2nd graders today where we talked about, 2 and 10. And I said, how many more is 2 than 10? They made 10 perfectly, they made 2 perfectly, and they went like this. So that's awesome. That's 10 and that's 2. So how many more? Can you see the more? No, I can't really see. I can see that it's more, but in this way, I can really see the more. You know what I mean? This part's the same, and that part's the more. So that's what I would, that's the kind of thinking we want to go after. You can use bar models to show comparisons, to subtract. 459 children were at the library yesterday. Notice that the numbers are getting a little bit bigger here as we move on in second grade. So draw a bar, call it 459, label it yesterday. 46 fewer children were at the library today. Well, today looks like that. And where's the more? The more's there. Where's the fewer? It's right there. How much fewer? 46. Because still, a lot of kids will label that 46 when we're starting out here. How many children are at the library today? That's this. In order to figure out how much that is, I want to start with 459, take away that little bit, and be left with the exact same amount as today. So here are your helpful phrases for addition, subtraction, and comparison in second grade. Draw a bar, call it fill in the blank. Is that part of the first bar or extra? Remember on that Will breaking his eggs problem? That's every single time we show that, it's a 24, and then right next to it's a bar of 7. Because that's what we just did. You draw a bar with the first number, the second number you see, you draw a second bar, call it that. The kids are really good at just kind of going for the steps of that, but that's not an accurate picture of the situation. And this question hopefully gets us at that. Is it part of it or is it extra? Where is the more, where is the less? Can you point to it, whether in cubes or in a bar model? What do you want to know? This would be a kid who's got a really darn good bar model and doesn't have a question mark on it, or drew a perfect bar model and then doesn't know what to do from there. What part of this do you really want to know? Do you want to know this part? Do you want to know this part? And where's the question mark? Again, just for kind of consistency for a good bar model. So, let's practice a little bit. Yeah?
So the single bar or the comparison bars,
Yes.
they're both correct.
Absolutely.
So is there a right or wrong way? Is the comparison one more advanced?
If I were to, it is more advanced, but if I were to put the yesterday bar here and the today bar here, I couldn't accurately label the 46 in space. You know what I mean? I could see that one's bigger than the other, but I can't actually show where that more or fewer is coming from. And that's the idea behind the where's the more. And it is a very subtle and tricky, I mean, it's a difficult thing. And we work a ton on that because they stack them side by side almost all the way through first grade. And so it's almost like we gotta break down that habit. Thinking of ways to do that as we get better at this. So let's say my students got this and we're working on homework and they calling me over, Mom, Dad, I don't get this problem. I don't understand. What would be the first thing that you say? Maybe have you read the problem? That's a good one. And then after that, yes, I've read the problem. Okay, let's read the first part together. Kevin scores 78 points in the first game he bowls. Draw a bar, call it 78. Call it his first game. He scores 85 points in the second game. Are those points part of the first game, or are they extra? Are they separate? Those are separate. There's my 85. Now, here's a very, I wish I could say this is intentional. Anybody notice anything goofy about this guy? 85 is smaller than 78. And this is an instructional decision on behalf of you as a parent and me as a teacher. Am I going to call it or not? I would probably say not. But because it doesn't really matter for their final, But as we continue to get more refined, that's something I definitely would call out in a fourth grade or fifth grade. Come on, look at your bars. That's not bigger than 78. How many points? I totally did that on purpose, by the way. How many points does Kevin score for both games? Well, if that's game 1, that's game 2. Both games looks like that. And now what am I going to do? Now how do I solve it? Well, I want to put these two numbers together, and that's addition. And we do it the old-fashioned way: 78 over 85, and 163. The art teacher has $745. Great. Now my child has gotten this far because they've heard you and me and their teacher and everybody, even their neighbors, say, draw a bar, call it 745, so many times that they've really got that step. Now what do you say? Well, now we're on the second step. She buys paint supplies for $257. This is one of those economics conversations that I was talking about. Where does that $257 come from? It comes from the money that she has. It would be the short answer, and fill in creative answers beyond that. But so it's going to be part of that 257. Now, could you draw this as another bar underneath it that represents 247 or 57, and still see that you're supposed to subtract? Absolutely. Is it a perfectly accurate way? I'd say not, because you're really double accounting for two sums of money, right? You got the money up here, and you've got that same amount here. You're kind of doubling it. Again, really picky that I work with on a kid who is doing a really good job at bar modeling, and I'm trying to refine the skill. But if I've got a kid who's really struggling with word problems, a kid who struggles with reading, where bar modeling can be a really awesome strategy because I get to take it a piece at a time, I would definitely accept a comparison style bar model. She spends the rest of the money on drawing supplies. Well, if that's the whole money, that's the money she spent, that's the rest. How much money do the drawing supplies cost? This is a subtraction problem. $745, take away $257. Okay. Try this one with your neighbors. This is the trick. If you haven't already, draw a bar, call it 225. So everybody's here, yeah? $78 left to spend. Is that $78 part of the 225 I spent, or is it extra?
Extra.
It is extra. And I get this is the challenge here, because the last one we did, it was part, and I was dealing with money. I'm still dealing with money, so it's probably going to be part again. That's the kind of thinking that we're going up against, and definitely what I would have said if I was learning it this way. But this is really a way to have the conversation and show that that's not correct. How much money did the library have at first? And this is going back in time to see that that's the amount of money that they had at first. And that's a tricky concept, I think, if the kid doesn't see it right away. But now that the kid has this model, you have really a way that you can talk about that tricky concept of, well, if you spend some and you have some left, and at first you had this much, it gives you something to talk about. And that's another reason why I really like bar model. Okay. Two-step bar models. This is where this is in grade 2. This is a really tough chapter for our kids. And this is where bar modeling really gets complicated. And this is the time where I remind everybody that bar modeling gets complicated because it forces you to understand the problem. And it's really the problem that's complicated, and the bar model then becomes complicated because you're trying to represent the problem. We're still just using addition and subtraction here, but this is going to get kind of tricky. Let's see how we do. There are 26 boys and 19 girls in a class. And I'm going to give you another try in a second. So if I'm going way too fast, please slow me down, but I do want to be careful of the time here. 26 boys, 19 girls in a class. Later, 7 children leave the class. How many children are in the class at first, and how many children are in the class now? This is a great bar model for how many children are in the class at first. I'm going to add those two numbers up. Then I could draw a second bar model to represent the number that I have at first and the 7 being taken away, and then the number that I have left. I could do that. It's is it an accurate representation problem? Absolutely. Does it get you to a correct answer? It tells me addition first, then subtraction? Absolutely. Totally great. But there is another way. And this is what I would expect more out of a 3rd and 4th grader. There are 26 boys and 19 girls in the class, and 7 kids leave the class. Where do those 7 kids come from? For the sake of this model, they can come from there. If the kid really wanted to put 2 here and 5 over there, I don't really know how many came from each. That's okay. But this would be a great way to do the bar model as well. So my first question is, how many children are in the class at first? That's right there. And my second one would be, how many children are in the class now? And this is another reason why bar modeling and helping kids with bar modeling is really hard. Because this is what we see when we're called over sometimes for homework, and this is sometimes what we see as teachers. And sorting through that, not with computer-generated bars and a second grade number, can be difficult sometimes. And the more it can be a conversation between you and the kid and us and the kid, we try and do that. And you guys are really in a unique position, much more than we are with a lot more kids, to have those kind of conversations. we certainly don't want, I didn't lead with this, but I do want to mention, we certainly are not trying, through this night and other kind of informational things, to push the burden of instruction onto you guys. You know what I mean? There is certainly, it is a totally legitimate thing to sign the homework and say, this wasn't happening tonight, they didn't know what was going on. And a lot of times they can get unstuck with saying a couple of these helpful phrases. And when they don't, I don't want to put the responsibility on you to reteach this stuff. Sign the homework and send it back. That's incredibly valuable information for us as teachers. It's sometimes, some would argue, I was definitely one of those when I was in 5th grade, it's more valuable information. I gave a quiz my first year here, and homework for coming back 100% on everything, and I gave my first quiz. And it was because parents were doing the perfect thing and helping their kids, but I wasn't seeing their real skills. I was using homework to base how's everybody doing. So that's my little spiel about that. Okay. Any questions? We doing all right? Okay. Here's where bar modeling really starts to pay off. Mr. Castro drives 341 miles. Mrs. Castro drives 279 miles more than Mr. Castro. How far do they drive altogether? Number one incorrect answer. I see the word altogether. I see two numbers. I'm going to add them up and write down my answer, and I'm done. But that's not what's really happening in this problem. Mr. Castro drives 341 miles. Draw a bar, call it 341. Mrs. Castro drives 279 miles more than Mr. Castro. So this is what her bar looks like. And so far, nothing new. Now, how far does Mrs. Castro drive? Well, in order to get that, I need to add up these two numbers. And then in order to find out how much they drive together, I need to take the sum of these two numbers that I added and add it to my original Mr. Castro. This is a two-step addition problem. And I would have answered, because I was really good and got through a significant amount of my elementary math career, by looking at two numbers and seeing the word more and tossing them together. And this really kind of exposes that as early as 2nd grade. Because the kids can add at this point, for the most part, with a little bit of assistance. But this is just, bringing their thinking to the next level. So I first find Mrs. Castro, and then I find them all together. This is a really nice little trick. When you talk about a comparison bar model, and you're talking about both of them all together, the best way to do it is to put your question mark off to the side here. It really shows, it's the way we use all the time in the text and in class to represent both things together. Is a huge bar off to the side. A little bit, and just not very intuitive, I don't think. So that's another trick for you. Okay, here is the first, this is getting towards the end of 2nd grade. Can you spot the small challenge? This problem is in some small way different than every other problem that we've looked at before tonight. Everybody see why this problem I would expect? This is not, on some level, this is a lot like what we've been doing for a really long time. But even a kid, especially almost a kid who's really good at bar modeling, why would I expect this to throw them a little bit more? How about now? I'm sorry? Because it is 3 steps, and my first sentence in every problem up until now has been an essential piece of information that I can draw a bar and call it whatever. Now I've got Tara and Jason collected stamps. Draw a bar and call it stamps. That's a little bit tricky. So if a kid drew a bar and called it stamps or called it Tara and Jason, it's great. That's awesome. And then in the second step, we'll kind of refine that. Or a lot of our kids at this point are comfortable enough that they'll kind of ignore that information, because despite our best efforts, they do still scan for numbers and look for more and less, and a lot of times it won't throw them, but sometimes it really will, because this isn't what we call chronological, where each sentence by sentence really gets you to the correct answer. So now Tara has 165 stamps. There they are. She's got 48 more stamps than Jason, which means Jason has less. And how many stamps do they have all together? So this one I need to subtract and then add. And that's really tricky. If you're skimming for numbers, there's just no way that you're going to get that answer. You're probably going to add the two numbers together, even if you use a great strategy like add 50 and take 2 away to make it correct with 48. You're going to see the two numbers and see them more and add them together. That's not even going to get you Jason, because we got to subtract, and then this is where the bar model really gives us a springboard to have that conversation with the kids. And there's my question mark to represent both of the things all together. Okay, try this one, please, with your neighbors. All right, I'm going to kind of reveal this one as we go here. A tall bookcase has 56 math books and 78 reading books. Are they part of the math books? Are they extra? Reading books and math books, they're separate. There's my 78. A short bookcase, totally separate bookcase, has 39 fewer books. How many books are in the short bookcase? Is this an accurate representation of the problem? Yes. Does it get me to a solution? In order to get a solution, I want to figure out what this is, take away that to get my final bar. Oops, there's my question mark. So this is an addition, then a subtraction problem, and I don't have the answer, I'm sorry. Does anybody want to shout the answer out? Does anybody? Okay. Because we're just focusing on bar modeling. We've got 10 minutes left. We're about to wrap up grade 2. Grade 3 is a lot more of the same. I'm going to get to multiplication before we're done here, multiplication and division. And then I am going to run out of time. So if you're a first grade parent and you're like, okay, that's enough for me tonight, please feel free to leave. I will not be offended. And as we run into time here, I'm going to try and keep going maybe 5 minutes over, but I'll stop there. And I'll put another YouTube video up or something. But please feel free at this point to leave if you need to. Thank you so much for coming. Absolutely, absolutely. And let's try and march through a little bit more before we go here. If you're a third grade parent, I hope that you don't find this not valuable because these are the foundations that have gotten your kid to where they are. And with those helpful hints and what we've talked about already, you can do an amazing job at helping them at home by getting them unstuck with those prompting questions. All right. Let's take a look at this one. An electronics store has 750 computers and television sets. Draw a bar, call it 750. And here I've got a label to show that these are computer and television sets. If I didn't have that label, that's okay, but it's gonna help me out here in a second. 429 of them are computers. Where are those computers? Are they part of this or are they extra? They're part of it, so my bar is gonna look something like that. The store then sells 86 television sets, and those come from right about there. What if this 86 was a little bit over here? Still accurate representation of the problem? Absolutely. And it's differences like that that really throw the kids. That's why I keep bringing that up. Is I'll put this up, and their 86 is over to the side, and well, mine must be wrong, or is mine right? And it's tough to have it. Is it an accurate representation of the problem conversation with a second grader? But we do our best. The store sells those 86 television sets. So how many television sets are not sold? That's this bit. So now I've got a perfect model. How do I solve this? Well, I want to start with this 750. I'm going to take away that part and take away that part and just be left with that. So how do I take away something twice? Well, I'm going to subtract the first one and then subtract the other one, and that's going to get me to my answer. Okay, now we're to multiplication and division, which is at the very end of second grade. And here's another takeaway phrase, although it's not on your helpful phrases sheet, and that is, it's all about equal groups. Multiplication and division is all about equal groups, especially in second grade. First, we start concrete. So I'm going to breeze through a couple slides here because they have nothing to do with bar modeling. But I do want to show you that there are ways that again, bar modeling is just one piece of the puzzle in Singapore math. It's a really popular piece of the puzzle. It's something a lot of middle schools and high schools have glommed onto because of its effectiveness. But it's just one piece. So when we first start teaching multiplication and division, we're using pictures and we're counting things. We're making equal groups of seashells. So this has nothing to do with the bar model, but it's how we teach multiplication to start out. Here's how I teach division to start out. Mrs. Carter's got 14 markers, and she divides them equally among 7 children. Those are the 7 kids, and they each have 2 markers in their hand. I can count it. I can prove that there's 17. I can prove that there's I can prove there's 14 markers. I can prove that there's 7 kids by counting them, and I can prove that each one of them gets 2. This is how we teach multiplication, with these little dot diagrams, where to do all my 2's, and they actually have things that we're going to try and make for at least my kids this year. And that is this sliding scale. So you can do all of your 2's times tables with this little piece of paper that reveals each one and really gets at the groups. Awesome, absolutely awesome. It gives a conceptual basis for flashcards. Can we still do flashcards when we teach multiplication this way? Absolutely. And what's the kid going to have in his hand when they're doing multiplication and don't know 2 times 4? One of these little slide guys to find the answer. Because multiplication are a great way to get the automaticity and a ton of practice really quickly. But we want a tool for them to use if they don't just look at the algorithm and know it off the top of their heads. So, another thing that's great about these bar models is we introduce new concepts, but we still have this familiar model that we've now been building for a couple years. So here we talk about the metric system for the first time, and we're talking about meters as a unit of length. And here we have a word problem that says a blue ribbon is 8 meters long and a red ribbon is 3 meters long. And a kid, on some level, can have no idea what a meter is, but part of this looks really, really familiar, right? I know that this is 8, I know that this is 3, this part's the same, this part's more. I would take away that bit to get the other one. So they get to glom onto this familiar model as they go. Here's another example. Jane walks 20 meters in the morning and another 35 meters in the evening. A lap around the couch or something, I guess. How far does Jane walk in all? Well, there's her 20 meters, there's her 35. And this is a bar model we've seen many, many times, but it's a novel, metric length is the novel part of it. Okay, another novel idea is when we start talking about money. And we teach money by counting plate bills, by adding and subtracting the way we all learned money with a lot of manipulatives that the kids can move around. But then we write things and we stack them and we add them up. But when we get to adding 3 different cents units, and we've taught in this lesson or the lesson immediately prior to it, how to say that 125 cents, 100 of those cents equal $1. So then there's my extra 25, so that's $1.25. This is how we get away with reinforcing really good math thinking and working with money in 2nd grade where we need to work with money, but when the kids haven't learned the decimal system to the hundredths, this is how we do it. And it's still very mathematical. It's really good thinking, but it's not the decimal form that maybe some of us learned. Then we get into modeling fractions. Here's where bar models become super versatile. The difference between fractions and kind of the rest of my things is I can see the phantom whole, right? Fractions are always part of a whole. So this is a half. In some problems, it would be perfectly acceptable to draw a bar and call it a half. And just, it'd be like any other bar model, but the part of it's labeled a half instead of 6. But here, in order to really drive home the point of fractions in this, when we're first teaching them, is that you can see what the whole would be, and that's half of it. You can see what the whole would be, and that's a fourth of it. So we can add like fractions in the end of 2nd grade by saying, well, that's 1/4, and that's 2/4, and together they're 3/4. Each one of them is 3/4. Aaron reads 1/3 of a book before dinner. Draw a bar. Here's where we just call it a third. Actually, no, we don't. There's the entire whole. Sorry. She reads more of the book after dinner. That's some amount. And she reads 2/3 of the book in all. What fraction of the book does Aaron read after dinner? So I've got the 2/3 in all, and the 1/3 over here. I'd take that away and get 1/3. Now, there's another sneaky difficult part about this problem, and that is, how do I know when to draw my second bar? For some, she reads some after dinner. If I drew it here, would this be a terribly good model? Not really. How about over here? Because the thing is that they need to be equal pieces, and this is where bar modeling is a little bit tricky. Again, what's our purpose? Is it an accurate representation of the problem, or accurate enough? Then it's okay. And this is the ultimate goal for bar modeling, is if you need a model to help unpack what's really happening in the problem and get an efficient solution, then use a bar model. But ultimately, we're talking 5th grade, 6th grade, 7th grade, high school. I don't need to force everyone to use a bar model if they can see that this is a takeaway problem because of what I've done before. Does that make sense? And that's a fine line, and we try and do our best as teachers, and that's all I can tell you. So multiplication and division, this will be the last thing we talk about, because we're 1 minute to 8 o'clock. 5 crackers are in a bag. Draw a bar, call it 5. There are 4 bags. So what would that look like? Well, if that's 1 bag, then 4 bags are going to look like that. And each one of them is 5. How many crackers are there in all? Looks like that. Here's my question mark. And we teach multiplication as repeated addition because that's what it is. And when kids are first starting to multiply, they can get a successful answer by adding a bunch of times. And there's nothing wrong with that. And as soon as we get to 5 times 67, hopefully we've got a more efficient strategy. And the kids then at that point want a more efficient strategy. But if they're adding that at the beginning of learning multiplication, that's just fine. So Shannon reads 3 pages of her book each day. How many pages does she read in 5 days. There's my 3 pages. There's my 5 days, kind of. And how many does she read in the 5 days? There's my question mark. That's 3 plus 3 plus 3 plus 3 plus 3, or 3 times 5, 15. It's another great one. I won't bore you with this for too long, but this is the exact opposite of everything we've done so far. Really awesome in-class activity, and kids will sometimes be asked to do it homework. This is totally the reverse, right? Here's a couple words, and here's a model. Tell me a story. What would be a story that would accurately represent this thing? And the kids love doing this, especially in 2nd grade. So I could say maybe Sam has 5 eggs in a basket, and then he's got 5 baskets for his chicken to lay many. Sorry, I didn't use all the words, but you get the idea. Okay, Barry buys 12 muffins. Draw a bar, call it 12. He puts an equal number of muffins into 3 boxes. What would that look like? Are those muffins or those boxes part of that 12, or are they extra? Well, that kind of gets a little bit harder at this point, but they definitely are inside it. They are part of it, right? So they look exactly like that. How many muffins are in each box? And here, I could solve the answer by trying to think of a number, guess and check, that would add 3 times to get 12. Or hopefully, very quickly, I can get to the division and figure out some of my division facts. And we teach them at the very beginning by thinking of the related multiplication fact, because multiplication is much more, the kids catch on to it a lot quicker, as did I. So we can say 3 times something is 12. Well, I know 3 times 4 is 12, so there's got to be 4 in each one of those. This is a very difficult part about division. I'll be honest with you, this is one thing that I bend on all the time, because the difference here is so subtle when I work with bar modeling with kids. And that is, Jason packs 15 shirts into boxes. He puts 3 shirts in each box. How many boxes does Jason have? And if you think back to this one, let's replace this number quick with 15. Right? He's got 15 shirts, and he places them 3 in a box. This is 3 boxes, not 3 in a box, right? They're both solved with division, and they're both 15 divided by 3. This is a truly accurate picture of what's going on. I've got a group of 3, I've got another group of 3, and I don't know how many groups I have of 3 until I get to 15. And it's tough. It's really, really tough. I get kids to do this a lot. This is kind of the goal that I try to get to with kids. And this is really as far as I've gotten. And I think at this point, that's okay, because they still get the correct answer, and it becomes more burdensome than it's worth at that point. It's not really effective if it just confuses them more. Kara feeds 18 treats to some cats. Draw a bar, call it 18. Each cat eats 3 treats. So instead of erasing and doing, sometimes I figured out that the dotted line kind of stresses them out, because they want to go back and erase it and make it dotted, or just like it is in the book, because they want to be right. So I start drawing them this way to really get at that, it's got to be efficient, it's got to be simple, so this is how I would use to show that. Each one has 3. So how many groups of 3 will get you 18? Well, that's 3 times 6 would get me 18, so there's 6 cats for those 18 treats. And here is the last thing kind of I'll leave you with for helpful phrases. If anybody does want to stick around and get a sneak peek into 3rd grade, I really apologize that I ran a little bit long and didn't get to it. This was helpful because it is, you can help your kids a lot with what we've seen so far. But if you want to take a couple peeks at some 3rd grade problems, please hang around and I'll stay as long as you like. Big ones, draw a bar, call it whatever, and how many groups, and how many in each group. Those are the most effective phrases I've ever used with kids to get them to see the distinction between this and this. How many groups and how many in each group. They're both division. Don't fight the fight for too long. But it's because they still understand division. They still understand the groups, but the model, actually drawing the model is what's hard for them. So I've fudged on that a little bit with kids, to be very honest. Okay, so that's Singapore math. I'm going to pause for a second, and if anybody has a question or any kind of overall questions at this point, and then if anybody wants to stick around, we can try. What would you say to me if I was stuck on this part? Jim has 30 pieces of wood. Thanks a lot for coming. Draw a bar, call it 30. So there's my 30. He uses an equal number of pieces to make 5 picture frames. So what would that look like? 5 different frames would look like that. How many pieces does he need to make each frame? Well, if those are the 5 frames, then that's one of the frames. And this is a division problem. I'm going to split 30 into how many? 5 equal groups, and there's going to be 6 in each group. I use my related multiplication facts to solve that. A couple of things you'll notice in 3rd grade. Bigger numbers, tougher computation. We're jumping into the thousands. And it's amazing to me, I've been teaching for a little bit now, and it's still amazing to me how a kid can do a problem, a 2-step bar modeling problem, subtraction, then addition, because they've done this bar modeling strategy and they get it and they're rocking it like crazy with numbers in the hundreds, and all of a sudden we throw a number like 5,099, which we'll see in a second, in one of these problems, and then they totally lock up because it's really hard to conceptualize unless you have a framework by which you've been conceptualizing it for several years. So in bar modeling, not a ton of new concepts coming in 3rd grade. That's why it's okay that we are going to not spend as much time on it, because all those bar modeling concepts have been built in 1st and 2nd grade, and a ton in 2nd grade. And now the numbers are just ramping up a little bit. The other thing that we have increased complexity. More often do we have a first sentence that isn't just draw a bar and call it. That's not a perfect strategy anymore, or even a 99% strategy anymore. Sometimes you really got to dig a little bit deeper in order to start your bar model. And sometimes we change course. Sometimes, based on the information we have, we draw a perfect model, and I realize on the 3rd sentence that my model isn't so perfect anymore. Best thing to do is cross it out and move on, or don't even cross it out. Just move on and start making a one that you think is better. The time it takes to erase is just a waste of time. So here we go. Nancy and Sue sold tickets for a concert. Draw a bar, call it tickets. Like that's what I'm saying. It's the chronological nature of it is a little bit more difficult. Nancy sold 3,450 tickets. So there's her 3,450 tickets. Sue sold 1,286 fewer tickets than Nancy. There we go right there. How many tickets did Sue sell, and how many tickets did they sell in all? In order to solve this problem, I'm going to need to subtract away to find Sue, and then whatever I find there, the difference, I'm going to add back to Nancy, and that's going to be my final answer.
Why in this, why do you do it in a top and a bottom versus just drawing the number in the one bar like you did earlier?
Because this would be the point at which I would say, where's the more? It's because you can't label the more. When they're side by side like that, I can't show you exactly where the more is. And that's like back with my 10 and 2 example. 10 is 8 more than 2. And here, where are the 8? Well, they're right here. You know what I mean? But here, if I ask you, where are the 8 that are more? They're right there. These ones are the same, and that's the 8 that's more. And that's why the stacking on top of each other is really, the best way to go. It is accurate if you stack them side by side, but the only problem is you can't label the more, the 1,286. It's a great question. Let's take a look at this one. A school has 720 girls. It has 250 more boys than girls. How many children at the school? And that's this one. The big difference between this one and the last one, which kind of thins the crowd a little bit in challenge for kids who get it right the first time, is because here they walk you through both steps, right? We're asking very explicitly, how much does Sue have? Because you can't get all of them together if you don't know Sue. And here, we're just expected that you know that because you've drawn the model. You know you want to add this and this, but you don't know that yet. So you got to add to find it and then put it back together. And if the kid just adds once and stops, 720 plus 250, and you get 970, then we'd say, okay, 970 is both of them together, or I'd have the conversation of how much does, probably the best, most efficient way, I'd ask the kid, how many boys are there? And when they go back and look at it, they tell me 970. I'm like, well, I thought you said 970, both of them together, and then hopefully we get the second layer on there. Prompted. 5,099 passengers on a cruise ship. 1,825 passengers are children. Are they part of this, or are they extra? Are children passengers? They're absolutely part of it. Awesome. How many more adults than children are on the ship? That's those guys right there. Now here's where I actually really, the best way I think to do this is to really draw two bar models, right? Because I can find the adults, but then when I want the question, how many more, in order to label it with a question mark, I really need to do this. Now, here's the part, starting in 3rd grade, where bar modeling is a strategy to get you to a place. And if you can get to the place on your own, I'd be fine with a student starting it this way, subtracting to find the adults, and then knowing that in order to find how many more, it's just a subtraction problem and stopping there. And that's okay. That's okay. Because we're just trying to use it as a tool to get to the next step. And if they can do it on their own, great. If I come to a kid who is stuck after this step, then I would help them through probing questions, draw that second bar model, and have a framework by which to have the conversation of why their answer isn't complete or correct yet. Mark pays $195 a month for rent. How much rent does he pay for all 3 months? 195 times 3. This is the part where we hope they have an efficient strategy. We could add 195 3 times, but it's much easier to multiply it. So this is some new familiar framework a new way of looking at things rather. And I know a lot of times I get a lot of parent questions when on homework. This is kind of the fill in the blank thing that we see, right? And we're going, at least when I first started this, was going, this is just 195 times 3. Like, what is all of these blanks that we have to fill out? Why are we making this complicated? But really, we're walking through the thinking of, well, if 1 unit is $195, then 3 units are 195 times 3, which is 585. And I would solve that out here. I'm not going to get that answer from just looking at this model. It's going to help me know that I need to multiply or add 3 times. Then I get my 585, and my answer is $585. So, we have a lot of conversations as teachers on whether or not, the extent to which we bring the kids through this fill-in-the-blank style thing. Because if you really truly understand this problem, then those fill-in-the-blank things, and if we're scaffolding it correctly in class, that should be attainable. But sometimes when we don't know, when we see it at home after a long day, it's just not there. And that's the point where the initials on the homework can send it back. We know, hopefully, that the kid had pieces of it or was almost there and understood the concept in class, but maybe is not ready to go all the way independently. And that's really good information for us as teachers. Here's one of my favorite problems in all Singapore math. This is a grade 3 problem. I want you to just kind of soak this one in for 1 second. Flo saves 4 times as much money as Larry. Maria saves $12 less than Flo. Larry saves $32. How much money does Maria save? Let's take a look at the bar model. Flo saves 4 times as much money as Larry. So there's Flo and there's Larry. 4 times as much. Maria saves $12 less than Flo. So that's Flo, so Maria's going to look like that. And Larry saves $32. Right there. How much money does Maria save? So what are the steps I need to go through to find this? In order to find Maria, I got to know Flo. And if Larry's 1 and he's worth 32, then Flo's worth 4 times 32. And whatever that is, Maria's worth 12 less than that. So the computation that's needed to solve this problem is 4 times 32, and whatever that is minus 12. And this is where Singapore Math tries to not just go farther by teaching, if the kid knows how to multiply 32 times 4, we don't want to then teach in the hundreds and then the thousands and then the 10,000s, but really we want to take what they know, double digit by single digit multiplication and subtraction, and go deeper. Okay, you know how to multiply, you know how to subtract. So now can we apply it in some complex situations? This is one very difficult problem where, among the entire thing. Singapore Math is not just throwing problems like this at kids, but it does go to the point where we're doing a really difficult problem here because when we're building the efficient bar modeling strategy, if that is in place, then we have a tool that we can use to have this. If not every 3rd grader is at this point, that's okay. Because we are still doing the multiplication, we're still doing subtraction, but we're definitely trying to go deeper with the application of those skills. Here we have some blanks here, which are just applied to this one. So if 1 unit is the only 1 unit I know right now, it's $32, that's Larry. Then 4 units is 32 times 4, or $128. That's the amount Flo saves. So 128 minus 12 is 116, and that's how much Maria saves. This is truly the last thing I will show you tonight, and that is, I think, another part where we can really see the power of bar modeling, as opposed to the strategy that I was good at when I was in school, and that is scan for the numbers and then try and find a keyword and toss them together and see what happens. So Sean and Trish scored 36 goals in all. And Sean scored 3 times as many goals as Trish. How many goals did Trish score? If I'm just scanning this for keywords, I'm going to see, and in numbers, I'm going to see 36 and 3 times, which is multiplication. So 36 times 3 has got to give me my answer, right? But that's not really what's happening in the situation. So if we represent Sean scoring 3 times as much as Trish, Sean's got 3 equal units where Trish has 1, and together they've all got 36. And this is where the helpful hint for 3rd grade, how many groups are there, or how many equal groups are there in that 36? Well, even though 3 is written in the problem, there are 4 equal groups here. So I'm going to divide that 36 by 4 and get 9 for Trish, and I could go back and find that Sean is 3 times 9, or 27. That's a complex thing to do, but with the bar model, it really helps unlock that skill. Really, this is 36 divided by 4, and we're trying to go deeper in the application of can you divide 36 by 4. Okay? So, I hope that you found a couple helpful hints to help get the kids unstuck. If you want to stick around and ask any questions, please stick around. Please take these things home. Tell people who couldn't be here tonight that we'll post this video on YouTube, and I really appreciate it.
Thank you. Thanks.